Okay, on 4.5, we're going to use the properties of logarithms to find the exact value of each expression. We already did the handouts on these, so you already know a lot of this. The book gives you harder ones because the handouts we did were from Algebra 2. Basically, what you need to know for some of the ones we're going to be doing now is these that I've listed. The log base of a base equals 1, basically because the base to the first power equals your base. Similarly, this is true. Natural log of 1 equals 0. That's because e to the 0 equals 1. And we've already gone over this as well. So we can start with the problems. We're going to start with 7 through 21 and do some of those problems. So the first one we have, and a lot of these we're going to be using as the power property. And that's basically why we like logs to begin with anyway. So we have log base 3 of 3 to the 71. Now, basically we're going to use our power property and bring the 71 down in front. So we get 71 times log base 3 of 3. Now, we already know that log base 3 of 3 is 1, so we have 71 times 1, equals 71. Okay, and now the same thing for the natural logs. We have 9, which is natural log of e to negative 4. This just means I can pull down this negative 4 in front using my power property. So that's negative 4 times natural log of e, and natural log of e equals 1, so I have negative 4 times 1, that equals negative 4. 11, we have 2 log base 2 of 7. So basically, from what I told you here, when you have something like that, we can just bring the 7 in front. We have 7 times 2 log to log base 2 of 2. This equals 1. So we have 7 times 1, that equals 7. Okay, 13. We have log base 8 of 2 plus log base 8 of 4. The first thing I'm going to do on this one is condense it, and I'm going to write as log base 2 of 2 times 4. Remember, this is like your m, this is like your n, and I can multiply these. I'm condensing, and that equals log, this is 8, log base 8 of 8, and we know that equals what? 1. Log of the base of the number, the same number, equals 1. Okay, 15. Same thing, we have log base 6 of 18 minus log base 6 of 3. I'm going to use my quotient property and divide this. So this would be your m and your n. Use your quotient property. This is log base 6 of m over n, which is 18 over 3, which equals log base 6 of 6, which equals 1. So, easy enough. 17 is log base 2 of 6 times log base, what? 6 of 4. So this one is going to be, I'm going to write this as, this equals log base 6 of 4 raised to the log base 2 of 6. Okay? And this equals log base 6 of 2 squared times log base 2 of 6. So that gives me log base 6 of 2 using my power property. I can move this 2 here. So log base 2 of, where am I? 6 squared. So that just gives you log base 6 of 6 squared, which equals 2. Because you just move this 2 in front here. Okay? And then 19 we have 3 times log base 3 of 5 minus log base 3 of 4. I'm going to condense this portion. So I have 3 log base 3 of 5 over 4. This is your m and n. And I'm just going to bring him in front. And so you have 5/4. This equals 1. So your answer is 5/4. And the last one is 21. We have 21 is log, I can hardly read this, log, 21 is not a log, it's an e, okay. So 21 is e to the log base e squared of 16. So what I'm going to do on this 21 is I'm going to let a, just because this is scary to me, a equal log base 2 e squared, sorry. I'm going to let this equal e squared to the 16. Then I know that e to the 2a equals 16. Okay? So what we're going to do next is do e to the 2a to the 1/2 equals 4 squared to the 1/2. So that means e to the a equals 4. So a equals ln of 4. So this whole thing equals 4. Because a equals what? A equals log, a equals ln of 4. So e to the log base e squared to 16 equals e to the ln of 4, which equals 4. So this whole thing equals 4. Okay? This 21 and this one right here, 17, we will definitely go over in class. Okay.